Okay, number 17. So we have f of x is x minus 3 all over x squared plus 9x minus 22, a rational function. Okay, again with a rational function, the problem is in the denominator. You cannot have a zero denominator, otherwise it's undefined. So we'll set the denominator equal to 0 this time, and we'll solve for x, and then that will show us what is not in the domain. Alright, so we've got x squared plus 9x minus 22 equals 0. I checked to see if I can do any common factoring first, but there isn't any. So you can factor this. This is x plus 11x minus 2. Okay, since this times this equals 0, that means one of these factors must be 0. So that means x plus 11 equals 0, or x minus 2 equals 0. So you solve these two separately. That's x equals negative 11, or x equals positive 2. So those 2 points cannot be in the domain. Everything else will work. You won't get a zero denominator. So it's a little bit of a hassle writing this interval notation here, but let's go ahead and do that. That's negative infinity. What comes first from left to right on the number line? Negative 11 comes before 2. It's to the left of 2, so you put that in there first, negative 11. We're not including that, that's not in the domain, so you put your parentheses next to it. Then you take the union. Now you go to the right side of negative 11 on the number line, so you put negative 11 on the left here with parentheses, and then go all the way to positive 2, but you're not including 2 again, parentheses, and then you take the union of that. Now you're going to the right of 2 on the number line, so you put 2 on the left side here with parentheses, and then positive infinity. So there's your interval for the domain, interval notation. Okay, number 19, another rational function. F of x is 2x cubed minus 250 over x squared minus 2x minus 15. So once again, we cannot have a zero denominator with these rational functions. That's the only time you're going to run into problems. So we set the denominator equal to 0 and solve for x, and that'll tell us what's not in the domain. X squared minus 2x minus 15 equals 0. These can be factored, or this can be factored, x plus 3, x minus 5 equals 0. So this times this equals 0, which means that this equals 0 or that equals 0. Alright, so you set that up separately. X plus 3 equals 0, or x minus 5 equals 0. And so x equals negative 3, or x equals positive 5. So x cannot be these two values, so the domain is everything else in the real number system. So to write our domain using interval notation, we have negative infinity to negative 3, union negative 3 to 5, union 5 to infinity. So we're using parentheses next to the negative 3's and the 5's because we're not including those in the domain. Number 21. We have f of x equals 2x plus 1 over the square root of 5 minus x. Alright, again, a rational function cannot have a zero denominator. So the only time you're going to have a zero denominator is if the radicand here is equal to 0. Square root of 0 is 0. So we can't have that. Alright, but there's another thing we have to consider. Since this is a square root here, we can't have negative numbers under the square root. So if we were to go 5 minus x is greater than or equal to 0, for example, that wouldn't quite work for this problem. Alright, it would work for the square root by itself. You know, 5 minus x would have to be greater than or equal to 0. We can't have a negative under the square root. But if it's equal to 0, then so if I wrote this, for example, 5 minus x greater than or equal to 0, and solve for x, then that would include 0 as one of the results, which is okay according to this. But it wouldn't be okay here because it would be in the denominator, a 0 denominator. Alright, so we have to modify that a little bit, get rid of that equals part there. What we want is something greater than 0 in the radicand. Greater than 0. We don't want 0, but we want something positive, not negative and not 0, right? Something positive. So that's what this is saying. 5x has to be positive. Alright, so solve for x on this. Just add x to both sides or move that x, negative x over, change the sign. Another way of writing this would be x is less than 5. That's easier to see the interval that way when you write it like that. So the interval looks like this for the domain, negative infinity to 5, but not including 5. So once again, if you did include 5, in other words, if this were set to be greater than or equal to 0, you would include 5, and you would have up here square root of 5 minus 5 is 0, so that would be 10 plus 1 is 11 over 0. So that would not work in this function because of that denominator. Alright, so if the square root function were by itself, it would be fine. Number 23, we have f of x is square root of x minus 6 over square root of x minus 4. F of x is square root of x minus 6 over square root of x minus 4. Alright, this is a little tricky because you have square roots top and bottom here. Alright, so in a rational function, we can't have a denominator equal to 0. That's the usual situation. Now, in this case, we have square roots both in the numerator and the denominator. So what you have to do is ensure that you're not having negative numbers under these square roots. Alright, so that's another little difficulty that has been thrown in here. Okay, so what we do is we set x minus 6 greater than or equal to 0. So it's okay to have a 0 up here, So I'll set x minus 6 greater than or equal to 0. And we also have to have this, so I'll put and here. Both of these have to be true. This cannot equal 0, and it cannot be negative. All right, so x minus 4 is greater than 0. All right, so this is saying that x minus 6 up here cannot be negative. You can have 0, it's okay in the numerator. All right, but if you take the denominator here, you cannot have 0 in here, right, because it's a rational function, and that's the denominator. You also can't have a negative under the radical, so this statement here is saying that x minus 4 must be positive, all right? And this is saying x minus 6 must be not negative, non-negative, or positive, or 0, right? So now how do you get the domain finally when you've solved these? Well, what you do is you take the intersection of those two solutions, all right? The domain will be the intersection of the denominator's domain and the numerator's domain. I'm talking about set intersection. Now, if you take the union, you could involve numbers from one domain which might not be in the other domain. So what you do is you take the intersection of these two domains, all right? So let's solve each of these separately. X is greater than or equal to 6, and x is greater than 4. So if you take the intersection of these two domains, x greater than or equal to 6, you're taking the left side is 6, including 6 to positive infinity, and you're going to intersect that with this, which is x is greater than 4. 4 to infinity. So this is equal to, when you take the intersection, what do they both have in common? Well, 4 is to the left of 6 on the number line. So everything in this domain here is going to be in this as well, all right? Now, not everything in this domain will be in this one, okay? If you put in like x equals, say, 5, up here, 5 is okay here, right? You get square root of 1 is 1. But 5 up here would be negative 1, right? Square root of negative 1. So that wouldn't work for that. So I'm taking what's in common with both. So what's in common? Well, this is in common with both. So the intersection is going to equal this. Okay, number 25. We have f of x is x squared minus 9x over x squared minus 81. So the only thing we have to worry about on this function is zero denominator. All right, so set x squared minus 81 equal to 0. We can't have a zero denominator in this one. Solve for x. Actually, this is a difference of squares, right? This is x squared minus 9 squared. 9 times 9 is 81. All right. So this is x plus 9, x minus 9, factored. So that means x plus 9 equals 0, or x minus 9 equals 0, and so x is plus or minus 9. That's not in the domain, plus or minus 9. So the domain then is negative infinity to negative 9 union negative 9 to 9 union 9 to infinity. Okay, number 27. For the following exercises, write the domain and range of each function using interval notation. So let me refer you to the book. In your exercise section, take a look at 27. Now the domain would be all the x values that go into this function. As you can see, open circle means that point is not included, and it starts at x equals 2, goes all the way to x equals 8. So the domain is the half open interval from 2 to 8, as you can see there. And as for the range, that would be all the y values. Starts at y equals 6, including 6, goes all the way up to y equals 8, but not including 8 because of the open circle. So for your range, you put the bracket next to the 6, indicating you're including 6, and next to the 8 you put a parentheses, meaning that you're not including the 8. And number 29, zoom in on this. So the domain goes from x equals negative 4 all the way to x equals 4, including both of those endpoints. So there's your domain right there. Negative 4 to 4 using brackets. Okay, and then for the range, the lowest points occur at negative 4 and 4, and they're both y equals 0. So the range goes from y equals 0, the high point is y equals 2 right there. So the range goes from 0 to 2 inclusive. Alright, so right there use brackets. Okay, number 31. So the domain goes from negative 5, x equals negative 5, to positive 3, but you're not including 3 because of that open circle. So it's from negative 5 to positive 3, but not including 3. So that's how you would write the domain as an interval. Bracket next to the negative 5, parentheses next to the 3. And the lowest point, the y value, is at y equals 0, right there. And the highest y value would be here at 2. Now this point over here does not include y equal 2 because of the open circle. However, this does include it. So when you write your range, you have to include 2 in the range. So you write a bracket next to it, because that is in the function, okay? Even though it's not present there. So from 0 to 2 with brackets.